Okay, starting out where we ended in the last video, where, as you can see, I said next video will be interpretation. So this is now our current video, if you can possibly even read that. So what we found in the previous video is that we could predict miles per gallon by taking 20 point, let's see, let me go back and get this, I don't want to mess it up, 32.83 minus 0.052 times a car's horsepower. So, for example, the predicted miles per gallon for a car with horsepower equal to 200 would be easy to find. Just by inserting $200 in our model. So let's pop that in the calculator real quickly. So 32.83 minus 0.052 times 200, and our predicted value would be 22.43. All right. So again, first thing we can do is we can use our model in a very straightforward fashion at 22.43 by inserting 200 in our model. Now, what if we had this graphically? In other words, what if we had a picture of just some generic X, some generic Y? We had some data. Someone had come in and fit the data with and let's say, for example, we had a value of 20, X equal 20, and we wanted to make a prediction. Well, guys, without knowing the least squares regression model, what we would have to do is we would have to make predictions. So we would essentially use our X value, come up to our model, come over to our Y value, and this would be the predicted Y. So we're going to run into that from time to time. But probably the focus of what I want to do in this video is to be able to make interpretations of our slope, which is negative 0.052, and our intercept, which I keep forgetting. I think it was 32.82. Let me go back and check that out. Yeah, 32.83. All right. In my opinion, if you were, when you were taught linear regression, sorry, not linear regression, but linear models, you probably had a teacher, instructor, professor, whatever it may have been, look at a very simple model and give you a table of values for this model. For example, they may have looked at some simple values of X, such as 0, 1, and 2. And if you put X into our model, you can see that we get a Y value of 2. If we put x equal 1 in our model, we get a y value of 5.
Oh, wow.
And put 2 in, we get a y value of 8. Now, let's first focus on the slope. Now, in my opinion, if you were taught well, your teacher, professor, instructor, whatever it may have been, should have pointed out to you that on the left-hand side, as we increase 1 unit, these y values increase 3 units. And it's more than just coincidence that the value these y values change, is precisely the value that we have for the slope. Guys, in my opinion, this leads in perfectly to the interpretation. And if we think about it, what happens as our x values increase 1 unit, the y values increase the amount of the slope. Now, that's a lot to talk about, so let's put this let's type it out. Okay, so interpretations. So in general, what we can say as x increases 1 unit, our y values increase 3 units. You know, bouncing it off the equation that we had before. Now for regression, this changes a little bit. So we would say as x, but guys, in our situation, x is horsepower. It's still going to be 1 unit. Our y values, because our y values in a regression model are predicted values. So our predicted y value, which in this case would be miles per gallon, now increases. Let's go back again to our model here that I used before. Notice that we're increasing because our slope is positive. If our slope had been negative, then these values would have actually decreased. So our situation that we have here, we have a negative slope, so we're going to expect our predicted values to decrease. And they're going to decrease the amount of the slope, 0.052 units. Now, again, going back to our model here, let's look at another one. Let's say, for example, that was negative. If we put these values of x in our model, we'll get the corresponding y values. Again, as we increase 1 unit over here, our y values go down by -2, or go down by 2, give us a -2, and this corresponds precisely with the value we get here. Okay? Leading us to our interpretation that's important for regression. So in this case, as x increases 1 unit, our predicted y value decreases 0.052. Now, what will change in future problems? I need to underline that because we'll have a different x. The increases 1 unit is always going to be the same because it's just the definition in general of our slope. Our predicted y value is the same because we're going to be doing a linear regression model. But that will change from problem to problem. The decrease will change from problem to problem because we could have a positive slope. And obviously the slope itself will change from problem to problem because we have different numbers. Now, let's go back to the illustration here. It's my feeling that, again, if you were taught well, your professor, instructor, teacher, whatever it may be, would have put a lot of emphasis on this line right here, pointing out to you that when x is equal to 0, y is equal to 4. It's by no coincidence that this 4 and that 4 are the same number. The reason? Because it's exactly the definition of an intercept. So again, right here we can say that when x is equal to 0, our y value is equal to 4. So again, staying in tune in general. And guys, this is for the intercept. Let me go up here and change this. I think it's clear, but never take it for granted. So when x equals 0, our y value is equal to 4. Now for regression, we stay with the kind of the core of our interpretation, but we would say when x, in this case horsepower, is 0, then our predicted y value, miles per gallon, is, and guys, go back to our model. Remember, our intercept was 32.83. Now, important note. Sometimes our intercepts are meaningless. This is the case with horsepower and miles per gallon, because when horsepower equals 0, it makes no sense in the context of our problem. I mean, seriously, if we have a horsepower 0, we're not going anywhere, so we're not going to be able to establish miles per gallon. This will happen sometimes, and the best way to interpret whether or not your intercept is meaningless or meaningful is just think it through. Use a little bit of statistical common sense. Does it make sense to have an x value of 0? Now, for example, does this intercept make sense? Let's say y equals the family household income, while x equals the number of children. Trust me on this one, as x increases, y goes down. As the number of children go up, your disposable family, and I should say family disposable household income. So, but anyway, does x equals 0 make sense in the context of this problem? Well, it's an astounding yes, because a household could have 0 children. While, in our example for horsepower and miles per gallon, it made no sense, of course, because horsepower could not be 0. So, guys, that's really what I want you to know so far. That's going to be all the lectures that I'm going to upload for missing class this week. So have a good one. Again, when you watch these videos, I want you to pretty much treat it as if you were sitting in class. Take notes, get this stuff in your notes, because when we come to class, we're now going to, have, at least an introductory understanding of the material, where we can, get in groups and work on activities and and examine data and so on and so forth. So we'll do that once we come to class. But it's probably really helpful if you can have a lot of this in your notes where you can refer to it when we work in groups. So guys, I'm out of here. Have a good one. See you soon.